Today we are doing system of inequalities. Now we've graphed inequalities before, but now a system means there is going to be more than one, at least two inequalities that we're graphing. And usually when I do this, I try to use two different colors because we're going to try to find the region where the colors actually blend. So let's start off with the graph. And we want to remember that when we're graphing inequalities, first thing you want to make sure is that your inequalities are in slope-intercept form. And as you see, the first one is not. So I'm just going to rewrite this by subtracting the 2x first. Then I have to divide by -1. Don't forget to switch the inequality. And then you can see that the second one is already in slope-intercept form. So then we proceed to graph. And let's see, the blue one, we start our graph at 3. Let me just give a little bit more tick marks. And then our slope is, you can either go up to right 1 or you can go down to left 1. And then always check to see if your line is included. And in this case it is, so it's going to be a solid line. And we're shading less than, so that's everything below. Okay. Then my other line we're going to do in a different color. We're starting at 1. This slope is negative. So you can either go up 1, left 2, or you can go down 1, right 2. This line is also included, so this line is solid. And it says greater. So that's everything greater than the line. And as you can see, where the two colors meet, let me give this one some more blue. This is the solution. And sometimes what I do is I take a highlighter so I can darken that area. Which I don't have a highlighter right here. But any point located in this region is a solution to the inequality. And you can always check by selecting a point, and if it makes both inequalities true, then you know that you shaded in the right area. So now I'm going to allow you to try one. Okay, I want you to solve this system by graphing, and then we'll check our answers. Okay, I hope the first thing that you did was get the first inequality in slope-intercept form. And I graphed the blue line starting at the y-intercept of 2, and my slope was -1/2. Then the second inequality was already in slope-intercept form, so I graphed that. And that y-intercept was at -1. And so I shaded the blue line less than, and the second line was greater. And I only showed this time where the solution region was. And there you have it. In this particular example, we are using inequalities to solve a word problem. It says a pizza parlor charges $1 for each veggie topping. I'm going to let that represent X, since they didn't give us specific variables, and $2 for each meat topping, and that'll be Y. And it says you want at least 5 toppings. So you always need an inequality or an expression to represent how many you have total. At least means it has to be that or greater. And you have only $10 to spend, so I can't go over the 10. But it was $1 for the veggie, so that's 1X, and $2 for the meat, that's 2Y. So that's my system. And I want to make sure, since I have to graph these, I get Y by itself. And I'll just, on this one, subtract X and then divide by 2. And it's difficult if you don't use graph paper. Because you can measure points up. So I'm going to try my best to do these. The first one I'll do in blue. Starts at 5, and my slope is -1. So I'm just going to keep going. And this is a solid line because it's equal to. And it says everything greater. So I'm going to wait to shade that. And then my second line I'll do in pink also starts at 5. And it says down 1/2. Down 1/2. Down 1/2. Down. See, and if you don't use graph paper, it makes it hard to line up. Down 1/2. Down 1/2. Down 1/2. Down 1/2. And this one says less. And that means that the region will be in between here. So anything here would work. And notice I didn't do everything since we're talking about pizza toppings. And money, I'm not going past 0. So anything in this region would be a solution. Now, what happens if you have a linear and an absolute value system? Well, we would graph those. First, I'm going to graph the line, but you notice both have Y by itself. So the first one is Y is less than or equal to 3. Well, we know that's a horizontal line at 3, and this line is included, so it's solid. And it's less than, so everything below I will shade. I'm trying to shade lightly so that we can still see the other tick marks when I graph my other equation. Okay, this one is at absolute value. Remember, we would start in the middle with our 5 points, and we would shift everything right one. So after your shift and your V is solid, this is what we would have. And since it says greater, it will be everything inside the V. But notice only where the colors mix will be a solution. And notice I'm staying below 3 because that's the first inequalities requirement. And then there you have it. Okay, I want you to try this one just to make sure that you understand how to graph a linear and absolute value system. So then we'll check our answers when you're done. Okay, on this one, I only showed the region where the colors would have blended. So the first inequality, my y-intercept was 1, and my slope was -1/3. So I went up 1, left 3, and I also went down 1, right 3, so you can see the entire line. Well, more of the line. My absolute value inequality, when I started in the middle at my 5 parent points, that too was a vertical stretch. So I had to stretch all my y coordinates by a factor of 2, and then I shifted everything right 1. So that's the blue graph. And my linear inequality was everything less than. So I shaded down and everything below. Then my absolute value inequality said greater than, so I had to shade everything inside the V. But I only showed where the two regions met. And that's how you'll see it when you check your answers. They're only going to show the blended region. So you can do the same, or you can show both and just make where they blend, make that region really dark so it stands out. And that's it for absolute value inequalities.